I'm going to turn on my video shortly. Those ones who have just joined, thank you for joining. I'm Teacher Linda. I'm going to handle mathematics this morning. So if you've joined, feel free, and let me hope you've taken the right decision to join this morning. Previously, we've been looking at fractions. Those ones who have always been joining, we've been looking at fractions, and we exhausted them in our last session. We looked at operation on fractions. We looked at different things about fractions, changing decimal numbers as well, and very many others. So those ones who are joining us for the first time, try to revisit the WhatsApp group, go through all the messages. It contains all the work that we covered in that previous session. So you can check there, visit that site very well. It will be of great importance and value. It will add value to your understanding. So make sure you visit them. Today we are going to start another subtopic. Still, it's in mathematics, not another subject. And I hope by the end of this lesson, we pick up something. All those ones who have just joined us, you're welcome to our online lesson. I'm Teacher Linda. My name is written down here. And my contact is there, so feel free to contact me and ask anything about our lessons. Feel free to contact me. And I hope I'm meeting primary 6 mathematics. Today I want us to look at the bases in mathematics. The reason as to why I specify in mathematics, there are also other subjects where you meet the bases. There are also other subjects where you meet the bases. So if I don't specify, it will be a disservice. Before we move that far, I would like to remind every one of us to send their parents' contacts in the chat section. Make sure you send the contact in the chat section. Put it there, the contact your parent, put it there as we are moving on. So that by the end of our session, at least there is the contact is already there. Thank you. Today we are looking at bases, and we are going to remind ourselves, because this is not the first time we've seen this topic. We saw it in primary 5. And now, so we are going to look at it and just revise something about bases. Bases, this can be a mode of counting in groups. Bases, this can be a mode of counting in groups, in different groups. But this time round, you realize that a different group, as you're counting in a different group, there are those things that we need to consider. And that's why we come up with these bases here. One, with the bases, each base contains digits that are equivalent to the base, to its name. We are going to see that in the due course of our engagement. One thing, some of the things here, each base has its special name. And for us in primary, we basically concentrate on base, from base 2 to base 10. That is our concentration. So I'm basically going to look at those ones there. We are just reminding ourselves, because I know we've already seen this work somewhere. We've already seen this, because this is studied first in primary 5, and later in primary 6. I was saying that each base has its special name. For example, base 2, when they talk about base 2, let us recall the first note I gave you, that is, each base contains digits equivalent to its base name. So base 2 will always have 2 digits, and when we are giving those digits them, when we are giving digits, we start from 0 and 1. So those are the digits in base 2. You realize that the base name is 2 and the number of digits are 2. Then another thing, someone may ask, teacher, why didn't we begin with 1, then 2? One thing we should always note, a base does not have a digit that is equivalent to its base name. It has the number of digits are equivalent to the base name, but the digit in that base, it does not contain the digit equivalent to its base name, because you realize this is 2 and the base name is also 2. So for that reason, 2 does not align with the digits that make up base 2. So in base 2, we have only 2 digits, that is 0 and 1. Let us see the special name for base 2, that is binary base. So you may find actually in our level, very few questions come across with the base 2, base 3. They will always ask using the special names. So we need to take note of them. The special name for base 2 is binary base. Then we have base 3. Its special name is ternary base. Then we have base 4. Its special name is quaternary base. Then we have base 5. Its special name is quinary base. We have base 6. Its special name is senary base. We have base 7. Its special name is ternary base. We have base 8. Its special name is octobase. And base 9, its special name is nonary base. Then we also have base 10. Base 10 has a number of names, and these are, it can be called the decimal base, it can be called the standard base, it can be called the normal base, denary base, and very many others. It has a number of names. So basically, that is all about bases. Those ones who have just joined us, we are trying to review and remind ourselves about the special names for bases, because that's what we are looking at. To remind ourselves, we've said that each base contains digits that are equivalent to its base name. And we've identified base 2. That base 2 has digits, has only 2 digits according to its base name. It has 2 digits, and that is 0 and 1. Those are the only digits for base 2, because it is in, when you count the number of digits we've written, they are 2 digits that are equivalent to the base name, that is 2. Then base 3 also has 3 digits, and that is 0, 1, and 2. Because we've said that some of the things we need to note, each base does not have that digit that is equivalent to its base name. That's why you realize that base 2 has 2 digits, 0 and 1, but 2 is not included because it is equal to its base name. Then base 4, Let me see someone here to give us the digits that form base 4. Digits that form base 4.
1, 2, and 5. 1, 2, and 3.
Yes.
0, 1, 2, and 3.
Good.
0,
Thank you.
1, 2, and 3.
Thank you so much. So the digits that form base 4 are 0, 1, 2, and 3. We don't exceed, because at first he mentioned 5, but when you add 5 here, when you add 5, it shows you that it has already gone beyond base 4, because these are already 5 digits, and we've said that each base has digits equivalent to its base name. So you find that base 4 has only 4 digits, that is 0, 1, 2, 3. So whenever you're doing any operation on these bases here, and you find that these bases have contained digits beyond the base name, we basically have to change them. We shall see that. Digits in base 5. Hema, digits base 5.
0, 1, 2, 3, and 4.
Thank you. 0, 1, 2, 3, and 4. So when you count them, you realize that these are 4 digits. Let us see also others here. Base 6, and we've said that the special name for base 6 is scenario base. We are going to also see this and see the number of digits and the nature of digits in this. Yes, Glorian. Oh, wait a little bit. Yes, Gloria. Digits in base 6. Your hand was up already.
0, 1, 2, 3, 4, and 5.
Good. 0, 1, 2, 3, 4, 5. Thank you so much. Karen, digits in base 7. You mute your microphone, then speak, okay? Stuart. Oh, someone's hand is already up. Karen, yeah, speak to us.
0, 1, 2, 3, 4, 5, 6.
4, 5. Oh, let me write here 0, 1, 2, 3, 4, 5, and 6. Thank you so much. Can we have the digits in base 8? Someone ready here? Let me check here. David? Oh, David is not ready. Okay, Stuart, you can give us.
0, 1, 2, 3, 4, 5, 6, 7.
Good. 0, 1, 2, 3, 4, 5, 6, 7. Thank you so much. Then base 9. Nondo, yes, please. You can give us.
0, 1, 2, 3, 4, 5, 6, 7, 8.
Good. 0, 1, 2, 3, 4, 5, 6, 7, and 8. Thank you so much. Then base 10. Base 10, let me see someone to give us the answer. Ambrose, are you ready? Ambrose?
4, 5, 6, 7, 8, 9.
One more time, please.
5, 6, 7, 8, 9.
I'm not hearing the first ones. I don't know that you're starting from 5. Repeat one more time, please.
3,
Guess
4,
what?
5.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9. When we count them, do they make 10 digits? We have 1, 2, 3, 4, 5, 6, 8, 9, and 10. Thank you so much. So this is just a review of bases. Then another thing we need to learn, how do we read bases? Let us check here. Yeah, I see the messages. Thank you so much, Melissa. Keep on sending your numbers, please, your parents' contacts, please. As we are moving on, keep on sending them. Yeah, I see some of us have answered in the chat. Thank you so much for being active. So let us also see something else here. I want us to learn, because we are reviewing about this. So I want us to learn something about these bases again. Reading bases, I want us to learn still. We've talked about we've talked about all the digits in each base. Now I want us to review ourselves about how to read bases. One thing we should note, bases from 1 to 9, and that one for us, we are handling from 2 to 10. So bases from 2 to 10 are referred to as they are called non-decimal bases. Don't mind about teacher has not told us about 11, 12, 13. Yeah, they qualify to be bases. But at our level, we are looking at only 2 bases from 2 to 9. 2 to 10. And we are saying bases from, we are saying that bases from 2 to 9 are called non-decimal bases. Non-decimal bases. So whenever they talk about non-decimal bases, just know you're dealing with bases from 2 to 9. Then base 10, remember the names of base 10, the decimal base. So when they talk about any decimal base, standard base, normal base, they'll be talking about or referring you to base 10. Let us take note of those simple things, and that's how we handle it. So bases from 2 to 9, according to how we are looking at them now, I'll not talk about 1, I'll not talk about 12 and the rest. I'm basically going to concentrate on bases from 2 to 10. Now let's move back to this group here. That is bases from 2 to 9. How do we read them? Let's assume we have 1, 2, 3, and that one can be read as 123. Base 4. We have that number there. How do we read, how to read bases? How to read bases? Bases are read this way. We read each number independently. So when we are reading, good. So when we are reading, thank you. When we are reading this one here, we shall read each digit independently plus the base name. So we shall read it as 1, 2, 3, base 4. We don't read it as 1, 2, 3, 4. No, that is wrong. You have to identify which one is the base and which one is the number for that base. So it is read as 1, 2, 3, 4. Then we can also have something here. Let me see someone to read us that one there.
5, 6, base 8.
Thank you so much. Then we can have another person to read for us this.
4, 5, 6, base.
Wait, we don't have the best name yet.
4, 5, 6, base 9.
Thank you so much. Melissa, this one is yours.
Yes.
210001.
There is no best name. Now read it again with the best name.
210001, base 3.
Yes, thank you so much. So that's how we can read the best name. We can read the bases. Vanshika, this one is yours. Wait a little bit. Can you see it? Someone is doing something on my screen and I'm not happy. Just make sure you remove it. Let me check this person. David. David, can you remove what you've done on my screen, please?
5, 6, 5, 4, 0, 7, 0. Yes.
Wait, I put the base name. So you can read it, Vanshika.
6, 5, 4, 0, 7, 0, 1, base 9.
Thank you so much. So these numbers, however big the number may appear, we still read it as one. We read them as independent digits, regardless of how many digits they've given you. That's how we read them. Then that is all about the non-decimal bases. Then we also have here for base 10. For base 10, the non-decimal bases, these digits are read. We read the whole digit. For example, this one here, we read the 34. And then another thing we need to note, yes? Whenever you find a number without a base, it belongs to base 10. Whenever you find a number without a base, it belongs to base 10. So they, you may find that they may not write there that this is 34 base 10. They may just write there 34, just like that, and you will have it in mind that I'm dealing with base 10. So we can read several digits together. We can you read the number as it is, that is 786. That is still belonging to base 10. So any number without a base, it belongs to base 10. So that's just a review of bases, and I hope at least now we've reminded ourselves about what happens to them. Then let us also move to the interest to them. Let us move to the interest to them. Bases, then we have operation on bases. When we talk about operation, we mean addition, subtraction, multiplication, division, all that can happen on bases. But today, I want to concentrate on addition and subtraction of bases. When they talk about addition and subtraction, I hope we all know what happens. Just adding, and you know when you're adding, unless you're adding a zero, the value of the number increases. We have an example there. Add 3402 base 8 plus 1023 base 8. So you come and arrange your digits very well. You arrange them vertically. Now we can add digit by digit. You have 2 plus 3, you will have a 3. But for our level, I advise us to have the side work. We can call it side work, or else we can refer it to part of work. So we can refer it to one of these. You choose one that is okay with you. Melissa asks, can base 10 replace base 2, or it can replace any base? No, unless you change it to that given base. We shall be looking at that as we have our other engagement. That will be our next engagement. We shall see, can we replace this base by this one here? Actually, we can do it after converting. I hope, Melissa, you've been answered. So this is what I advise you to have when you're dealing with bases, that is the side work. So in your side work, you'll have 2 plus
3.
Will give you answer 5.
5.
So you come and put it here that this is 5. Why do we use side work? It helps you determine whether those digits belong to that base, yes? And then we have 0 plus 2, you get 3. You also come and put it in your side work before you write the answer there. Sorry, 0 plus 2. Ambrose, you're doing something on my screen. Remove it. Giving you answer 2, you also come and put it there.
2.
2. Then 4 plus 0, write it in the side work. You come and put it there, that answer is 4. Then 3 plus 1, put it in the side work. You get the answer as 4. Now, what happens when you add and you get an answer that is beyond the base? Let us see our example 2. Let us see example 2.
4 to 5 base 8.
So the answer is, 4 to 5 base 8. That's the answer for that number there. Then let us see if we are dealing with, we have add 2, 3, 2 base 4 plus 1, 2, 3, 4 base 4. So you still arrange them very well vertically. And we've said that the best thing to do with such is to prepare the side work. You can call it side work, all part of the work. So you will start, we start from the right when we are adding. The order does not change, so we shall have 2 plus
3.
We get answer 5. So ask yourself, do we have, someone has already a question. Karen, yes, please. Yes, Karen?
It was by mistake.
Yes? Okay, we can't hear you. Then you can send your question in the chat. It's okay. Type it in the chat, then I'll read it and respond to it. Colleagues who have questions, put them in the chat. I'll be answering them. So when you get answer 5, you realize that digits in base 5, in base 4, we have 0, 1, 2, 3. These are the only digits that are put in base 5, in base 4. So what do we do to this base, to the answer here? We get this answer and divide it by the base name, which is 4. The answer you've got, whenever you add and get the answer beyond the given base, yes, you divide it by the base given, and this one will give you 1 remainder 1. 1 remainder 1. So we shall have one whole number, remainder 1. So what we do, we write the remainder there and the whole number is regrouped. We take the whole number in the next place value. So we shall have, when you go to the next, we shall have 1 plus 3 plus 2, giving us answer 6. The moment you realize, because 6 is bigger than 4, it does not belong to this base, we shall divide it by 4. When you divide 6 by 4, we shall get one whole number, remainder 2. That 2 is written as our answer here. The remainder is written as the answer. Two is written as the answer here. Then the whole number is regrouped. So we shall have 1 plus 2 plus 1. And this will give us 1 plus 2 plus 1. It will give us answer 4. But remember, 4 is not written in that base. So we shall divide it by 4 still. 4 divided by 4, which will give us one whole number, remainder 0. So when the remainder is written as the answer, that is 0, then the whole number is regrouped in the next place value. So you find that under the next place value, there is no any other digit. So we shall have plus 1 plus 0, which will give you a 0 base 4. That is when you add and find that you have the answers beyond the base given to you. That's basically what you do. You convert them, you change them, or you divide them so that they can suit the base you are dealing with. And we consider the remainder. Why do we consider the remainder? Let us see something here. When you have 5, and we'll say that 5 divided by 4, we get answer 1, remainder 1. And we are asking ourselves, why do we take the remainder? Let us see something here. The 5 balls will be 1, 2, 3, 4, 5. And when you're sharing, you're going to have one group of 4, one complete group, and a remainder. Yes? So the reason as to why we don't take the whole number is equivalent to the base. Yes? So you find that the whole number has 1, 2, 3, 4. That is it's a complete group. That's why we don't take it. But we take the remainder because for the remainder is less than the base. Just see you're doing something on my screen and I'm not happy. So better remove them. Yes, Melissa, the remainder is the answer. The remainder is written as the answer and the whole number is regrouped. That is the addition of bases, unless someone has a question about the addition. If you have a question, please, I'm giving chance to everyone to ask anything. Pretty, do you have a question? Yes, Karen, your hand is up. Just stop what you're doing on my screen. Karen, yes, please. Yes, Karen. She's not, I think it's by mistake still. Anyone with a question? David, do you have a question? Okay, you can type them in the chat. Oh, someone has asked a very good question. Aaron, I've seen your question. What if the bases are different? Wonderful. We are going to look at that the next time, because when the bases are different, you have to change them to a common base. So we are going to see how to turn all those bases to one common base. I hope I've answered you. When the bases are different, we are going to see that, because it is some broad thing we need to really exhaust. Jesse, you failed to remove what you've done. Okay, it's okay then. It's okay. Melissa is asking a question. Why is the whole number regrouped? That's what I've explained here. We've said that the whole number is equivalent to the base. Because you find that here when we try to show it out, Melissa. Yeah, is it Melissa? Yeah. Now, when you try here, we have 5 divided by 4. We get one whole number, remainder 1. And how does the whole number come? After grouping in fours, when you have your 5 balls and you group in fours, you realize that you have one group, that is the whole number. So the whole number you have is equivalent to the base. And remember, we are not writing the equivalency of the base. But the moment you regroup it, yes, in the next place value, it becomes of the less value. But the moment you write it under that very place value you're dealing with, it's like when you're adding and you realize you've got answer 12. You find that you write the first one, that is 2, and then you regroup 1 to the next place value. And when the moment you cross a whole number to the next place value, it becomes equivalent or less than the base. It becomes less than the base because now in the next place value, it weighs something bigger than that one you've taken there. So most of the time it chips in that base. I hope I've answered you, Melissa, because we even illustrated it here. Any other person with a question about addition of bases? No one with a question, okay. People are putting them in the chat. Okay, Melissa, thank you. I've seen it. You've been answered. That's great. Let me see. Timothy, you've been quiet. Do you have a question? Timothy, do you have a question? Yeah. Nondo, you've asked the same question as Aaron also asked. What if we are adding different bases? I've said that we need a common base, and it requires us to do a lot about it, so we need to convert them. So for that case, I don't want to handle it now. I want to give it an engagement. So in our next engagement, we are going to look at such scenarios. Let me hope I've answered you well, because right now, I can't move into those conversions, convert this, but we are going to look at them after this, in our next engagement, those scenarios where you're told to handle out operation on the same basis. Thank you. Any other person with a question? Let me hope, Nondo, you've been answered, and that applies to Aaron as well, as you asked that question. Any other person with a question still? Okay, so what we are going, so next, I'm going to give you a piece of work that is also containing subtraction. I want you to try to go through it. When you find a challenge, write it down. In our next engagement, we shall start with subtraction. And yes, Pascal, your hand is up.
Yes, thank you, Teacher Linda.
Yes.
I wanted to pass a small announcement. I'm going to ask Emma, specifically Emma and Ambrose, someone who uses Emma and Ambrose,
Yes.
and someone who says Emma alone, if they could send in their numbers. Emma and Ambrose and Emma.
All right, I hope they've had Emma and Ambrose, Emmanuel and Ambrose, you send your contacts, then Emma also, send in your contacts, please. So we are I'm going to be sharing this work in our group. I'm going to be sharing the work in our WhatsApp group. It contains subtraction as well. So I ask you to try out different numbers of subtraction, please. You're going to go through this work. I'm not going to teach it right now, but I just want you to have some, just to have time with it and note down something. You find a challenge, please. I'm just going to send all this piece of work. Just go through it, and we are going to have it we are going to have more time with it in our next engagement. Otherwise, bye-bye. I wish you a nice morning. Thank you for attending. Bye-bye, everyone. Thank you for attending.
Bye, teacher.
Bye-bye.
Bye, teacher. Thank you.
Bye, teacher.
Bye-bye. Melissa says, how about division? We are going to see how best we can do it. We shall learn it in our next engagement. Just make sure you remain with us, subscribe, so that next time we meet and we have time together. David, thank you so much for attending. Have a nice day. Try to practice that work and send feedback in the WhatsApp group. You can also send them on my number.
Bye.
Bye-bye. May God protect you, bless you.
Bye, teacher.
Bye-bye.
Bye-bye, teacher.
Bye-bye. If you have something you're saying, you can ask.
Eh.